We talked in an earlier video about an application of the derivative as the velocity of an object, if the function that we have is the position function of the object. So let's say again that f of t, this is the position function for some object, okay? Actually, we'd usually call this s of t. So if s of t is the position function for an object, then if we take the derivative, we get the velocity function. Velocity function. Right? And again, this gives us a function that for any time t that we're allowed to plug into it, it'll tell us the velocity of the object at that time t. Okay? Well, oh, sorry, there wasn't supposed to be a prime there. All right? So, well, we can take the derivative again, right? No reason we can't do that. Right? That's the derivative of velocity. So it's the instantaneous rate of change of velocity. What we call that is, I'm going to call it a of t, and this is the acceleration function. Right? So this tells us sort of how fast our velocity is changing. Right? So think about the, how you press on the accelerator in a car and you're kind of like pushed back into the seat. That's your acceleration that you're experiencing. Right? You can't feel velocity, but you can feel the acceleration. All right. So, now that we have that, let's do an example of computing an acceleration function. So let's say we have an object moving along a straight path with this position function, right? 1.7 t squared minus 3.1 t plus 6.8. Okay? So let's say that this is the position function of some object. Okay? So we want to know what's the velocity, what's the acceleration. All right? Well, the velocity. Okay, so this is going to be the limit as h goes to 0 of s of t plus h minus s of t. Oops. Minus s of t over h. Okay? So this is limit as h goes to 0 of 1.7 t squared. Oops, sorry, t plus h squared. There's probably not enough room here for that. Let's move this down. Okay. T plus h squared minus 3.1 t plus h plus 6.8. Right, and then minus just s of t, 1.7 t squared minus 3.1 t plus 6.8. Alright, all of this over h. Alright, so this is going to cancel the t here. This will cancel with this. And here, let's see what we get next. Come on. Alright, so we get limit as h goes to 0. This is 1.7. We've got t squared plus 2ht plus h squared minus 3.1h minus 1.7 t squared. And again, this is going to cancel with this. Alright, that's all over h. So, I'll let you sort of work this out on your own, but this should simplify most completely to, let's see, this will be 3.4 ht, oops, sorry, 3.4 t plus 1.7 h minus 3.1. Okay? And we compute that limit, and we get 3.4t minus 3.1. All right? So this is v of t. All right? So that's the velocity function right here. And then if we do this derivative again, so a of t equals limit as h goes to 0 of v of t plus h minus v of t over h. All right. I'm going to let you work out on your own that this is all going to simplify to just be, let's see, what are we going to get? We should get just 3. Well, okay, let's do it. I can't do it in my head. Alright, so this will be 3.4. Right? T plus h minus 3.1. And then minus 3.4t minus 3.1. Alright, and it's all that over h. Alright, so this cancels here. This is going to cancel the t. Okay, it's exactly what I thought it was. Alright. This is just going to leave us, when we simplify, is just a 3.4 here. So 3.4 is our a of t. Okay? And this is our acceleration function. Alright. So hopefully that all made sense. And see you in the next one.